August 1943, Dobodura Airfield, New Guinea. The tropical heat hangs like a suffocating blanket across the dispersed fighter aircraft arranged in neat rows across the runway perimeter. Technical Sergeant James McKenna walks between the P-38 Lightnings with the unhurried gait of a man who understands his territory completely, who has studied every rivet and cable and fitting on these aircraft until they are as familiar to him as his own hands. He is not a pilot. He will never fire the aircraft's weapons in combat. He will never experience the terror of enemy fighters closing rapidly at relative speeds exceeding 500 miles per hour. His war is fought in maintenance sheds and on tarmacs, fixing damage, replacing components, ensuring that aircraft sent aloft will function reliably when pilots depend on them for survival. He is 42 years old, a career mechanic who apprenticed in civilian life before the war conscripted his skills into military service. In that moment on August 17, 1943, as he stands beside a P-38 assigned to a lieutenant named Joseph Hayes, McKenna is about to make a decision that will violate every protocol in the Army Air Force Maintenance Manual, that will constitute disobedience of superior officers' explicit instructions, that could result in court-martial if discovered, and that will nonetheless be replicated across dozens and eventually hundreds of P-38 Lightnings across the Pacific Theater. The problem McKenna confronts is not dramatic in appearance. It consists of approximately 3/8 of an inch of slack in the aircraft's aileron control cables, the cables connecting the pilot's control stick to the movable control surfaces on the wings that enable rolling maneuvers and banking turns. The slack exists because Lockheed's design specifications, refined in California manufacturing facilities and approved by Army ordnance, permit this tolerance. The specifications are considered conservative and safe, designed to prevent overstressing cables and control linkages. The tolerance is authorized. The slack is permitted by regulations. The problem is that in aerial combat, 3/8 of an inch of cable slack translates into an approximately 300 millisecond delay between pilot input and aircraft response. 0.3 of a second might seem negligible in civilian flying. In aerial combat, where Japanese Zero fighters can execute turn rates that American fighters cannot match, where pilots must respond instantly to threats, where the pilot who sees the enemy first and reacts fastest typically survives the engagement, 0.3 of a second represents an eternity. It represents the difference between successfully evading an attacking fighter and taking cannon fire through the fuselage. McKenna has spent weeks listening to pilots return from missions complaining about sluggish control response. He has studied combat reports documenting engagements where American fighters should have prevailed, but instead were damaged or shot down. He has observed pilots explaining how they saw Japanese fighters executing turns the P-38 pilot could not match with the required speed. The pilots are not blaming themselves. They understand that the aircraft's design limitations are not limitations of pilot skill, but limitations of mechanical lag. The P-38 is fast. The P-38 climbs well at altitude. The P-38 is powerful and durable. But the P-38 cannot turn with the Zero in any meaningful sense because the control cable slack introduces delay into every control input. McKenna, who possesses intimate understanding of mechanical systems and who has thought deeply about the physics of flight control, understands that the slack is unnecessary. The slack is designed into the aircraft not because it improves performance, but because it represents a conservative engineering margin that assumes worst-case scenarios that do not typically occur in practice. He raises the concern through proper channels. He approaches his squadron's engineering officer with a detailed explanation of the problem and a request to reduce cable tension below authorized tolerances. The engineering officer responds with formal military language. "Negative, Sergeant. Control cable tension is within permissible specifications established by Lockheed and Army ordnance. Field mechanics do not possess authority to modify aircraft systems. Any such modification would void the aircraft's warranty and expose the United States military to liability. Furthermore, such modifications constitute unauthorized alteration of military equipment and constitute a violation of military law. Do not attempt to modify this aircraft." The response is clear. It is final. It is supported by regulations, chain of command authority, and legal liability considerations. It is also, in McKenna's judgment, wrong. He consults with other mechanics, men he knows and trusts, men who have worked on P-38s for months and who share his concerns about control response. The conversations are conducted quietly, carefully in tones that do not carry. He discovers that other mechanics have noticed the same problem. Some have contemplated similar solutions. All have concluded that direct request for modification authorization is futile. The chain of command will not authorize field modifications that violate official specifications. The only path forward, if a path exists at all, is unauthorized modification conducted secretly and hidden from discovery. McKenna contemplates this calculation carefully. The potential consequences are severe. Court-martial is possible. Discharge from the military with dishonorable status is possible. Yet pilots are dying because of a design tolerance that McKenna understands is unnecessary and modifiable. On the evening of August 17, 1943, McKenna obtains a length of piano wire salvaged from a damaged aircraft awaiting repair. He carefully measures and cuts 6 inches of wire. Then he bends the wire into a Z-shaped configuration, creating a simple mechanical device with approximately 4 pounds of tension built into the bent wire. The device will function as a cable tensioner, introducing additional tension into the aileron control system that will eliminate the slack. The fabrication takes approximately 6 minutes. The installation takes approximately 2 minutes. McKenna installs the device on the P-38 assigned to Lieutenant Joseph Hayes, in a location where casual inspection would not detect it. The modification is completed in near darkness, conducted with minimum motion, with no witnesses, with no documentation. When inspection crews arrive the following morning, they perform routine maintenance checks: fuel levels, oil quantities, ammunition loading, engine conditions. They do not examine the control cable tension closely. McKenna does not volunteer information about what he has done. The aircraft is cleared for flight. Lieutenant Joseph Hayes, assigned to fly a combat mission against Japanese positions on August 18, 1943, climbs into the cockpit of his P-38, unaware that his aircraft possesses a modification that violates military regulation. He conducts the standard pre-flight checks, feels the responsiveness of the control surfaces through the control stick, detects no obvious problems. The aircraft feels slightly different than previous aircraft he has flown, but the difference is subtle, almost subliminal. The engines start reliably. The aircraft accelerates down the runway and climbs into the New Guinea morning. Somewhere during the patrol, Hayes encounters Japanese Zero fighters. What happens in the next 7 minutes becomes immediately legendary in the squadron. Hayes shoots down 3 Japanese aircraft in rapid succession. He executes maneuvers and turns that should be impossible for a P-38 to execute. He engages Japanese fighters on terms favorable to American tactics rather than Japanese tactics. He returns to base with stories of an aircraft that responds instantly to control inputs, an aircraft that can turn effectively, an aircraft that is finally capable of dogfighting Japanese fighters instead of relying purely on speed and altitude advantage. The impact ripples through the squadron immediately. Pilots ask questions about why Hayes's aircraft performed so differently. Hayes initially is uncertain about the modification and hesitant to discuss it openly, understanding that acknowledging unauthorized modifications could result in investigation and consequences for McKenna. But word spreads through the rumor network that operates in military organizations, through mechanics and pilots talking quietly, through stories that become embellished with each retelling until the modification becomes almost mythical. A secret technique, a hidden modification, a trick that somehow makes P-38s capable of turning with zeros. Within days, other mechanics approach McKenna, requesting the specific details of the modification. McKenna, now understanding that the modification worked exactly as intended and that pilots' lives are being saved, shares the technique with trusted colleagues. By September 1943, approximately 40 P-38s across the Pacific have been modified through unauthorized field engineering conducted by mechanics who fabricate their own cable tensioners from salvaged piano wire. The phenomenon accelerates as word spreads. Pilots who have flown modified P-38s request reassignment to fly only modified aircraft. Pilots in squadrons that lack modified aircraft request their mechanics implement the modification. The performance difference is so dramatic and so obviously beneficial that the modifications spread faster than official communication channels can suppress them. Officers who discover the modifications face a dilemma. The modifications violate regulations, but the modifications are saving pilots' lives. The modifications are improving tactical effectiveness. Pilots flying modified aircraft report higher kill ratios and higher survival rates. The institutional response is complicated by the fact that the modifications actually work and that enforcement of regulations would require grounding improved aircraft and returning them to inferior baseline configuration. Some commanders attempt enforcement, ordering mechanics to remove the modifications. Other commanders tacitly accept the modifications, while maintaining official position that such modifications are not authorized. But McKenna's cable modification is only the beginning of the broader transformation that field mechanics implement across the P-38 fleet in the Pacific. Other mechanics, observing that control response improvements yield tangible tactical benefits, implement modifications addressing other performance limitations. Sergeant Leo Harriman, working with a different squadron, focuses on engine performance. The P-38 is powered by twin Allison V1710 engines equipped with superchargers. The superchargers are controlled by thermostatic valves that regulate coolant flow to intercoolers, heat exchangers that cool the compressed air before it enters the engines. The thermostatic valves are designed conservatively, restricting coolant flow to maintain engine temperatures within a temperature range deemed safe by Allison engineers. The restriction limits performance. Harriman, understanding the thermodynamics of supercharged engines and having calculated that the temperature margins are more conservative than necessary, experimentally bypasses the thermostatic valve on an aircraft he is maintaining. He locks the intercooler doors permanently open, allowing maximum coolant flow continuously. The aircraft is assigned to a pilot named George Prey. When Prey flies the modified P-38, he reports extraordinary performance improvement. The climb rate increases dramatically. The aircraft now climbs at rates approaching late-model Spitfires, an unprecedented achievement given that climb rate has been one of the P-38's most significant limitations at high altitude. The engine operates at higher power output. The aircraft is faster at altitude. Upon recovery, Prey's aircraft is still glowing red from engine heat, still steaming from coolant systems operating at maximum capacity, still performing admirably despite the stresses imposed by the modifications. Prey designates his aircraft the lightning that could run from hell. News of the modification spreads. Other mechanics replicate the engine modifications. By October 1943, supercharger modifications have become endemic across multiple fighter squadrons in the Pacific. The experimentation continues. Mechanics discover that water methanol injection can enhance performance further. Water methanol injection, properly controlled, cools cylinder heads and allows increased boost pressure. The official water methanol system uses a carefully formulated mixture and is controlled by timing systems that limit injection duration. Field mechanics experiment with pure methanol injection and with increased injection pressure. The modifications produce extraordinary performance gains. Pilots report over 200 additional horsepower at altitude, dramatic increases in climb rate, acceleration that seems almost impossible for twin-engine aircraft. Pilots flying modified P-38s describe the experience of returning to unmodified aircraft as going backward in performance, as becoming dependent on aircraft that suddenly seem underpowered and sluggish. One pilot describes the contrast as the difference between driving a truck and driving a sports car. The metaphor captures the performance gulf between specification configuration and field-modified configuration. The modifications violate explicit design protocols. Allison engineers specify coolant flow limitations for reasons they consider valid. Lockheed specifies cable tensions for reasons they believe appropriate. The Army Air Force specifies equipment limits for reasons it considers necessary. The field modifications disregard these specifications. The modifications are implemented without authorization. The modifications are conducted by mechanics who possess empirical knowledge, but lack formal engineering credentials. The modifications introduce stresses exceeding design margins, yet the modifications prove undeniably effective. Performance improves. Pilot survival improves. Tactical effectiveness improves. Engagement statistics demonstrate unambiguously that pilots flying modified aircraft survive encounters that pilots in unmodified aircraft do not survive. Inevitably, word reaches Lockheed's engineering headquarters in Burbank, California. An examination team is dispatched to the Pacific to investigate the field modifications, to understand what mechanics have accomplished, to determine whether the modifications are beneficial or dangerous. The engineers arrive with mixed intentions, some hoping to validate the modifications, others hoping to demonstrate that the modifications are unsafe and should be prohibited. What they discover is a mixture of admiration and institutional alarm. The modifications work exactly as described. Dynamometer testing confirms that the modifications produce the performance increases claimed. Temperature margins, though operating at the edges of design specifications, remain within acceptable limits even under sustained maximum power operations. The modifications do not cause mechanical failures. The modifications do not produce unreliability. The modifications produce superior performance without apparent degradation in reliability. Yet Lockheed management faces institutional complications. The fact that field mechanics have discovered improvements that official engineers missed is professionally embarrassing. The fact that mechanics possess better understanding of the aircraft's actual performance characteristics than engineers does is institutionally troubling. The fact that field modifications violate design specifications raises liability questions if the modifications are officially endorsed and if something subsequently fails. The company cannot simply endorse the modifications without acknowledging design limitations. The company cannot prohibit the modifications without appearing to prioritize bureaucracy over pilot survival. Lockheed's response is institutional avoidance, neither official endorsement nor official prohibition. The company maintains official position that modifications are not authorized, but the company does not threaten prosecution for field mechanics implementing modifications. The official silence becomes implicit acceptance. The Army Air Force's response evolves similarly. Initial response is to threaten court-martial for mechanics implementing unauthorized modifications. Senior officers prepare legal documents citing violations of military regulations. Enforcement is attempted in some commands, but the accumulating evidence proves overwhelming. Modified P-38s score higher kill ratios. Pilots flying modified aircraft report higher survival rates. Mission success rates are higher with modified aircraft. By mid-1944, institutional resistance collapses. The Army Air Force tacitly accepts the field modifications. By late 1944, the modifications have become so widespread and so clearly associated with American air superiority that they become de facto standard operating procedure. The modifications cease being illegal and become accepted practice. The P-38 pilots who benefit from these modifications achieve extraordinary success against Japanese fighters. Richard Bong, flying P-38s in the Pacific Theater, scores 40 confirmed victories, the highest total of any American pilot. Thomas McGuire, flying modified P-38s with the 475th Fighter Group, scores 38 confirmed victories, the second highest total. Both men achieve their success flying aircraft whose performance has been dramatically enhanced through field modifications. Both receive the Medal of Honor. Neither gives particular credit to the modifications in their official statements, attributing success primarily to superior tactics and aggressive flying style. Yet their success is achieved partly because mechanics have been willing to violate regulations to give them equipment capable of competing with Japanese aircraft. The story of P-38 field modifications illustrates a fundamental organizational tension. The officially approved design, tested extensively by engineers in controlled environments and certified as meeting specification requirements, proves suboptimal when confronted with the realities of actual air combat in actual Pacific conditions. Field mechanics and pilots, possessing intimate understanding of actual performance and willing to challenge official orthodoxy, implement improvements that bureaucratic processes have prevented. The improvements are effective despite violating design parameters and regulations. The institutional response, initial prohibition, gradual acceptance, eventual incorporation into standard procedures, reflects the difficulty organizations face in adjusting to evidence that contradicts official positions. The P-38's transformation through field modifications represents only one aspect of the broader evolution of the aircraft from promising but flawed design into one of the war's most effective fighters. The aircraft possessed inherent advantages: twin engine power, excellent range, superior altitude performance. But these advantages were limited by design specifications that appeared deliberately conservative. Mechanics in the field, responding to pilot feedback and observing actual combat performance, implemented modifications that transformed the aircraft. Engineers at Lockheed, confronted with evidence that field modifications outperformed factory specifications, gradually incorporated improved designs into production models. The P-38J variant, introduced in August 1943, incorporated intercoolers mounted in distinctive chin fairings, a design inspired partly by field mechanics' understanding of cooling system requirements. The P-38L, introduced in 1944, incorporated additional improvements. The modifications ceased being unauthorized by the time late production variants entered service. But the process by which modifications became official illustrates how military innovation occurs in wartime. Thomas Maguire's combat record, achieved through exceptional piloting skill and aggressive tactics and flying aircraft enhanced by field modifications, exemplifies the stakes involved. Maguire's reputation as the most effective combat pilot in the entire United States Army Air Forces after August 1943 was built partly on superior tactics, but substantially on flying aircraft at absolute performance limits. His crew chiefs reported that every P-38 Maguire flew became bent out of true, with rippled skin and popped rivets from the violent maneuvers he subjected the aircraft to. The modifications that enhanced performance enabled Maguire's aggressive flying style. Maguire continued climbing victory totals through late 1944 and early 1945. On January 7, 1945, attempting to save a fellow pilot from enemy attack, Maguire performed a maneuver at low altitude with full fuel tanks that the P-38 could not execute. The aircraft either stalled or structurally failed. Maguire crashed and died instantly, his final victory total 38, one victory short of tying Richard Bong's record of 40. The mechanics who implemented the field modifications were never formally recognized. The files do not record their names alongside the high-scoring aces. Technical Sergeant James McKenna's contribution is relegated to footnotes in technical histories. Sergeant Leo Haraman's innovations are acknowledged only within aviation enthusiast circles. The other mechanics, whose names are not recorded in any official document, implemented modifications that saved American pilots' lives and contributed directly to American tactical effectiveness. Their contributions, profound and direct, remain unacknowledged in official military history. Yet the field modifications they pioneered, implemented against regulations and contrary to official specifications, represent the accumulated wisdom of men who understood intuitively that official specifications did not represent true operational limits but rather conservative design, margins that could be exceeded safely if exceptions were managed carefully. The P-38 Lightnings that flew from Pacific airfields in 1943, 1944, and 1945 carried within them the accumulated unauthorized engineering knowledge of mechanics who recognized that official specifications were minimum guidelines rather than maximum capabilities. The aircraft that resulted from field modifications flew faster, climbed faster, and turned better than the officially sanctioned baseline configuration. The pilots who flew these aircraft achieved victory not only through superior tactics and exceptional courage, but through equipment that field mechanics had possessed the wisdom and the moral courage to improve despite regulations prohibiting such improvements. Epilogue. The P-38 Lightning remained in production through 1945 and flew in reduced numbers through the immediate post-war period. Some were converted to reconnaissance variants. Others became training aircraft. A few were transferred to Allied nations. By the early 1950s, most had been retired from service and scrapped. The field modifications that transformed the aircraft from specification-limited fighter into decisive, war-winning interceptor ceased being necessary once the modifications had been officially incorporated into production designs. The mechanics who pioneered the modifications lived the remainder of their lives, knowing their contributions had mattered, knowing that their willingness to challenge authority and break regulations had saved pilots' lives, knowing that their technical innovations had contributed to American victory. The P-38 Lightnings that achieved legendary status in the Pacific War flew as they did because technical sergeants named McKenna and Haraman and others, whose names are not recorded, understood that sometimes regulations must be violated when adherence to regulations results in unnecessary death. The 6-inch piece of bent piano wire that introduced the control cable modification revolution represents more than a technical detail. It represents the principle that field knowledge sometimes understands truths that official specifications miss, that organizational learning sometimes requires individuals willing to break rules to accomplish what rules prevent, that victory in war sometimes depends on people who possess the courage and the moral clarity to violate orders. when following orders means accepting preventable failure. The P-38 Lightning's legacy includes not only the aircraft's technical achievements, but also the example of mechanics who possessed the courage to innovate illegally and the wisdom to understand when innovation was necessary regardless of official prohibition.